Hi, Trevor. Thanks for your email. Sorry to take so long to get back to you. I just am going to give you my best insight into your question here. I can explain it to you for most of it. There's some parts on here that I'm not sure where the numbers came from, so we'll get to that, okay? So I've included a website as well in my email that has some examples similar to this, or at least I think the first example on that page is similar, so it might help you also. When you start with your general matrix and you reduce it down to the row echelon form, then what we're looking for is something that they call pivot points. And pivot points are the first non-zero number in each row. So they call that the leading value in each row. And what that helps us do is if we're looking at this in terms of bases for rows or for columns, then those are the important ones that we're looking for, okay? And so when you have your solution, let me just bring this down here, which is the other thing that you sent me here. Just the bottom of it. I couldn't get it all on one screen. My computer wouldn't show it. When you look at your basis, let me see where I can, sorry, I don't mean to do the Blair Witch thing on you here. Okay, when you're looking at the basis up here for your row H, then you'll notice that the rows that you are taking are row 1 and row 2 and row 3 for that from your original matrix. And I'm hesitating because I'm looking back at that and wondering if that was the original value there, because it looks like some of those values don't match. I'm not sure where. Just a minute here. Okay, for some reason it seems to translate down to here before the values match up for your row basis, where we have row 1, row 2, and row 3 matching with the basis that you've got listed there. I guess because as soon as you get to the ones and the leading values, you can stop there. You don't have to keep going. And so that would be the final matrix that you would need. If you take those 3 rows, that's your row basis for H, and that's rank, or dimension 3, okay? Rank 3 as well. For your column basis, it's just doing it the other way. It's doing it with columns. And again, we're looking for the columns that have those leading values in it, those pivot points. And so it's column 1, column 2, or 3, and column 4 there, okay? And that's where those values are coming right from. In this case, column 1, and then column 3, and the negative seems to be different there for some reason, and then column 4. So I don't know if maybe all the answers, all the numbers weren't copied down correctly because they're not matching up, but that's where those values should come from when you're setting up your basis for your row and for your column, okay? And so because there are 3 rows that have the pivot values, then that's why our rank is 3 and our dimension for H is 3. And so the dimension for the null H is always sort of the complement. If there's 5 columns, then 3 are with pivot points, then the other 2 will make up your null. And that's why the dimensions are 2, because the 2 plus the 3 always has to add up to the 5 again. So that brings me to my confusion. Sorry, that's going to mess all that up there, but I want to make this just a bit bigger because I want to talk about the bottom part here. You've got x2 plus x3, and I'm not sure if you are trying to write the solution set for the whole matrix. If you are, then I think if we said that it was, what did we say? It was 1, 2, and 4? 1, 3, and 4, right? then I would think that you would want to list 1, 3, and 4 there. If it's the null, then you would want x2 and x5 there. So if these are rows, okay, so if these are rows and this is your solution set, then we should have an x1 as well in there. Because basically what it's saying is that the other two, or if we're just doing rows, let me see, yeah, the fourth row should be a linear combination of the first 3 rows. And so if that's what we're listing here, sorry I'm hesitating, I'm just kind of thinking this through as I'm talking. If that's what we're actually doing, if these are the rows in this set, then I think that we should have an x1, because I think that this solution here is meant to be the linear combination of your matrix, of the rows in the matrix that are independent, and x4, because it zeroes out, which is your fourth row, is a linear combination of the other 3 rows. It has to be if it zeroes out. And so I think that's what this statement at the bottom is supposed to be saying, but without more information, these numbers aren't matching up for me to anything that I'm seeing, and what you're sending me, they're not matching up exactly. So I think we are having a little bit of translation issues with the numbers, and then I think that I'm just not clear at the end what it is that you're writing the solution for, and that's my best guess based on what I've got here. I'm sorry I'm not more clear, but I think that is what they're looking for, and you may find an example in your textbook that goes through it in more detail there. So I hope that that's a little bit of help. I know I can't be any more specific because I think some of these numbers are just a little bit off, and they're not matching up with the rows and the columns that I think they should.